So the further we get along into logarithms, the more properties we're going to need to properly use them. So the first property we're going to talk about is this change of base formula. So if we let a and b and x be positive real numbers and a not equal to 1 and b not equal to 1, then if we have log base a of x, we can convert that to any different base as follows. So if we have, let me zoom in on these three. Log base a of x, you can change it to log base b of x divided by log base b of a. Or if you want to use log base 10, we got log base a of x, the same one that we started with, equals log of x equals, log of x divided by log of a. Now, a quick reminder on these logarithms. If there's no base written there, we choose base 10. We call this the common logarithm. It's one of the most common, in addition to the natural log. It's one of the most common logarithms that you'll use. It's so common that it gets its own button in the calculator, and it's so common that mathematicians got lazy and they didn't want to write that base 10 over and over and over. So if you don't see a base, you can assume it's base 10. And you could also use base e. So you could use natural log of x. So log base a of x, you can make natural log of x over natural log of a. So I'm going to have us do this problem together, and then I'll pause, and then I'll have you do the second one on your own. So it says evaluate the following logarithms using the change of base formula. So we got log base 4 of 25. My advice is do log of 25 divided by log of 4. So I'm going to show you how to do this on a calculator, so let me switch screens a second. So on our calculator, we have a log button. It's off to the left side here. It's right next to the 7. So we'll do log of 25, close that parenthesis, divided by log, oops, sorry, not goodness gracious, I wasn't looking. Log of 4, close your parentheses, and it gives you 2.321. So I'm going to jot this into notes in a second. But to kind of verify that it works, remember, it's the base of your original logarithm, which was 4, raised to that power should give us 25. So if I do 4 raised to that power, if I do second negative, gives us the answer. It's 4 raised to that previous, that 2.32 or 321 or 322, I should say. It should give us back to 25. And it does. So jotting that down, that gives us log base 4 of 25 equals, well, log 25 divided by log of 4. I'm going to say after we round it, that's about equal to 2.322. Now again, to check your work, go back to the original. So log base, I'm going to just rewrite this. Log base 4 of 25 equals 2.322. Now to check your work, take your base, raise it to that new value, so 2.322, and maybe I should make a squiggly equals because we're rounding it. And if you were to plug it in exactly as it was, I'm not going to show this in the calculator, but 4 raised to the 2.322 gives you about 25. On my calculator, it gives me 25.002, so it's pretty darn close. So the final answer, log base 4 of 25 equals 2.322. I'd like you to take a few moments, try out log base 2 of 12, pause the video and come back, and you've clearly done it. So we got log of 12 divided by log of 2. Again, those are base 10 if we don't write a base there. But if you're feeling ambitious, or really it's the same number of keystrokes, you could do the natural log of 12 divided by the natural log of 2. So you can use either of those on the calculator. I'm going to do the natural log on my calculator. So I'm going to demonstrate that for you in just a second. All right, there you can see that I did type in that 4 raised to the raised to the 2.322, and it gives us about 25. Sorry that it's a little blurry. I'm using a webcam at home right now. But now I want to try the log base 2 of 12. I'm going to use the natural log. So I'm going to do natural log of 12 divided by the natural log of 2. And to show you that it works regardless of what base, so we get about 3.584. And again, we could have done log of 12 divided by log of 2. So it really doesn't matter what base you use, you're going to get the same answer either way. And again, to check our work, I'm going to do 2 raised to the 3.58. I'm going to round to the 585, 3 decimal places. And that should give us approximately back equal to 12. And you can see that's pretty close to 12.000. So if I rounded to 3 decimal places, it'd be 12. That's not bad.